So my name is Konstantinos Papadopoulos, Kostas for short, it's a mouthful. I am an electrical and computer engineer from Greece, and for the past 5 years I've been working as a software engineer, mainly with Python code bases. I've been also doing some interesting open source, like our stuff, which was actually presented here last 2 EuroPythons. So some cool stuff. So a few years ago, one of my friends sent me this very popular meme. So the number one legitimate reason to slack off, compiling. And he was like, yeah, compiling equals coffee time. To which I replied something like, yeah, then I guess we Python devs don't really slack off. Well, that's not that true. Fast forward a few years later, and figures out we can also slack off, and that's waiting for our test to complete. But jokes aside, having worked with some code bases with hundreds or thousands of tests, there are some cases where the time for the test to complete can be really counterproductive. So let's see why. A typical workflow is something like this. You write a failing test, you write some code and try to make it pass, or vice versa, depending on your school of testing. And after that, you might want to run a few integration or end-to-end tests to see that what you've created works well with the rest of the code. So then you might see that something is not correct. So you go back, fix your code, run again the inner tests, and run again your integration tests. And finally, when you have something ready, you can give it to your peer for that useful review, where you get 50 comments, and then you have to go back and run again all your tests just to make sure everything is correct. So this process can get you out of your zone while coding, and it can actually mean a lot of less time getting that useful feedback. Besides that, most continuous integration and continuous deployment pipelines have testing at some step of the pipeline. So when you have that critical bug out there and you want to fix it as soon as possible, waiting for that test to complete might be critical, and I do not advise to just skip them. And nowadays, with most CI/CD pipelines running on the cloud, it could mean higher test time could mean a bigger bill at the end of the day. So today, we're going to see some simple and quick methods. So I'm not going to show you very intrusive methods, not to restructure necessarily your whole test suite, on how to address slow test suites. We're going to be discussing a step right after measuring. So in business scenarios, you typically want to profile and find your bottlenecks. Premature optimization is the root of all evil. So we're making this assumption and trying to see what we can do from that point after. And we're going to be, sorry, forgot to click. We're going to be talking mainly about the PyTest framework, one of the most popular testing frameworks. But I like to think that the principles generally apply to whatever you use. So let's talk about fixtures. You might have seen some in the previous talks as well. So basically, in software engineering, fixtures are some entities that you can reuse to set up a service or mock some data. In PyTest, a fixture is as simple as just decorating one of your functions with a PyTest fixture decorator. And you can reuse that, for example, instead of passing your parameters every time in your tests, just using that fixture. So fixtures in PyTest are actually really useful because instead of just reusability, they offer also a specific lifecycle handling of the entity itself. So, okay, we saw a simple dummy fixture before, but usually we use fixtures to set up processes like a database. So when you're setting up your database, it's something repetitive, something that takes time, and you don't want to do that necessarily for every one of your tests. So here we have a simple fixture that with a sleep of 2 seconds just to simulate the database connection, and we can reuse that if we have 2 tests, for example, reading from our table and writing to our table by passing them as arguments to our test. And PyTest also takes care, and after the tests are run, it will clean up the session. So if we run these tests, it will take about 4 seconds to complete, right? We added a 2-second mock delay, and by default, PyTest creates the fixture every time we pass it to one of the functions, to one of our tests. So what we can do in this case is define a specific scope. We can say that we want these fixtures to be cached in the scope of a module. And we have other options as well. We can say that we want the fixture to be persisted throughout the session, or if we're using classes, we can also do that. So in this case, the test will run about 2 seconds, since we're caching the fixture and reusing it. Let's see another way of saving a lot of time. So we have here a small fixture, again, with a dummy delay of 2 seconds, and we create 11 plus 1, 12 tests. So the way PyTest would run that, by just running the test, will be running sequentially the tests one by one. So that will take about 12 times 2, 24 seconds. We can also see that there's actually only one process running in our machine, the one PyTest process for testing. So modern machines usually have multiple cores, and some of them even support multi-threading, and we can take advantage of that. So we can have a simple controller that distributes the test into different workers. In this case, our workers could be processes that are taking care of our multi-core machine. So one way to do that, again with PyTest, is with a PyTest xdist plugin. PyTest plugins are simply packages that extend some functionality of PyTest. So the way we do this here is we just call PyTest -n auto, which means use the number of physical cores that my machine has and run the tests. So you see here that it takes about 4.5 seconds instead of 24 that we saw before in a typical run. In this case, 6 workers were spawned, and that is because my machine, the machine I ran it on, had 6 physical cores. And you can also see that the processes that are created in your operating system are the 6 workers are this from PyTest plus the controller process that runs. So this is a great way to distribute in your own machine the tests and make them run really quickly. But that's not only limited to your machine. You can do something similar also with on your CI/CD. In this scenario, I use GitHub Actions, and you see that this typical machine has 2 threads in one core, and you can, instead of running with a single CPU that takes about 25 seconds, you can use the amount of logical cores and say that run it like that. So that would be about 12 seconds. A nice other little neat trick I like to do when I'm working locally, especially if we're working on a large monorepo, is set up some Git hooks. So Git hooks are executables. They're scripts that you can run before specific stages of Git. So you can say before committing or before pushing your code, you can run something. So what you can do here is, if you know that some tests are directly impacted by your work, like if you're working on a specific team, you can specify an entry point and say that you can use PyTest xdist to run those set of tests, and it will be much quicker since you're using the full capacity of your machine. So this would look like something like this. In this case, I just amend something, but it's really good before pushing your code just to make sure your tests pass before running on CI or CD. So this method is great for unit testing, which are usually isolated tests. You're not writing into multiple databases. And it's also great for running on your device, which are typically nowadays really strong devices. And there are some things you might want to consider is the fixtures we talked about, the reusability of them. It's a small trade-off, of course, when you're using this distributed method. And you can also think a bit more about how you distribute the test to the workers. So what I showed just uses a default distribution per module, but you can define per class or some other options. There are some caveats, specifically with PyTest exist, like that you cannot see the standard output, and you cannot debug with PDB, but that's just one plugin. You can also create your own implementation. You can play a bit with hooks if you want to go more advanced. And generally, you can form it in a way that suits you. So we saw how to distribute the test in our own machine. We can also do something on multiple machines. We can split our tests. So similarly, we can create different groups of tests and have a distributor that shares it around multiple machines. This is great for end-to-end tests and integration tests, which are usually a bit heavier tests. You can run it on your CI, where you can spawn multiple machines, and you can get some quicker feedback, since if something fails on one of the machines, you can already start working on it. And we will see how we can do that with the PyTest split plugin, another PyTest plugin, using PyTest markers, and of course you can use any other release strategy to split the test. So using the PyTest split plugin, you basically define the number of splits, the number of different machines you want to run the test on, and run them by group as such. There are two basic algorithms. You can use splitting based on duration-based chunks. So as you can see here, the absolute order of the tests is maintained, and basically the algorithm just finds the optimal border to split them into. A bit more suitable algorithm might be also, and a bit more optimized, the list durations, where here the relative order is maintained. So test 4 is after test 1, test 5 is after test 2. But the way this works is that this plugin goes over the list of tests and adds it into the bucket with the least time for testing. And you can get that specifically by also using the PyTest stored durations and running that every now and then. If you don't, PyTest test split will just use an average test time. Again, you can use that, as we mentioned, on CI, and it looks like something like this. You can use the matrix to define the number of different machines you want to run it on, and you can just call PyTest with the specific split. So yeah, if we see that it will take about 8 seconds per group. Again, the initial was 24, running it sequentially. Now, we can also use PyTest markers. So you can simply go to your tests and make whatever definition you'd like. You could say that, just by adding a decorator, that this is a fast type of unit test, or that this is a fast type of end-to-end test, or a slow end-to-end test. And you can run them based on that, based on the marker and some metadata, again, to get some quicker feedback, not block your tests between one another. All right, so we talked about the actual testing part, but before that, there's usually a setup part, especially in CI, when every time you have a clean slate. So this is the part where you download your Python or not dependencies. And if you cache that part, it is great for if you have large and frequent builds, and in general, if you want to minimize network calls. So there are some really easy ways to do that already. If you're using GitHub Actions, again, you can do it on any CI. But if you're using GitHub Actions, there's the setup Python action that you can use with the cache pip option. So what it does is that the first time it looks on the requirements.txt file, and the first time you create a file as such, it caches it. If you don't change it, it recognizes that the hash hasn't changed and reloads from the cache. This also is supported for pip files, so you're using pipenv or poetry log files for poetry, and you can also use, there's another action for UV. So yeah, first time, as we said, pip cache is not found, takes about 7 seconds, and if you don't change the requirements.txt file, it will take a bit less. In my specific example, I don't have a lot of outside dependencies, but if you're generally downloading a lot of stuff, it will save you a lot of time. So in the interest of time, I'm not going to show the configuration, but a lot of us use containerized applications like Docker to test. So you can also apply some caching here. You can also take advantage of Docker's layer caching, and something that takes about 2 minutes without caching can be minimized to a minute. This is just for a very simple base container, and we can also save some important time. Now, I promised that I would mainly talk about non-intrusive techniques, but this is something really interesting I read in a book named Architecture Patterns with Python. So it's differentiating what to test versus how to test it. So let's see a very simple example. We have 2 types of messages that we want to use in a small sending client application. We have a text message and a picture message with some text. And what we want to do is a very simple application. We just want to, if it's a Monday, send a picture message. If it's a Friday, send another picture message with some other test. And if it's just a boring other day, just send a text message. So if we would go about what to test, we would just do something like this. So for every different scenario, we would actually call this send message function and see that it returns what we expect. So that would take, in a specific example, about 3 seconds. We added 1 second of delay. And basically, what we're doing is interacting every time with our external system. So if we shift our mindset a bit to how we want to test, we can just create another function called createMessage and return the message type. So if it's, again, if it's a Monday or a Friday, it's a type of picture message, and that day, just a text message. And we can call that function from inside sendMessage. Now, we can just test that the right type of message is returned per scenario. And of course, we can also test our client. But we don't need to test every single scenario for the client. We can just have this right level of abstraction and see that everything works from there. So this would be much faster. It's a bit shifting from the integration and end-to-end tests to the unit tests that were mentioned actually also in some of the previous presentations. Some other things you might want to watch out for is, this is also for production code, always use timeouts. Also in your tests, don't leave them hanging. If you have some retry or sleep logic, you might want to set it a bit different for example, by checking an environment variable if you're in a staging or production environment. And you can also set, we mentioned a bit quicker feedback before, you can also set an argument like max fail. So after 25 tests have failed, you can just go and work on them since you already have enough work to do. But I kept the best method for last, and that is that you cannot have a slow test suite if you do not have any tests. Just kidding. Thank you for your time.